complex numbers, numbers that aren't real. Get excited. We can't take the square root of a negative number because there's no number squared that gives us a negative value. So we cannot undo that squaring and end up with something real. So to deal with that, we have the imaginary unit, I, which equals the square root of negative 1. Okay? So we just say the square root of negative 1 is I. And then if we square it, we get just negative 1. Because when we square I, it cancels out that radical, leaving us with just negative 1. So we're going to be using that fundamentally for pretty much everything else in this unit. And then when we move into solving quadratic equations and looking at different roots, we have to remember that the imaginary unit is the thing that exists and make sure that we're writing things in the correct notation. So just like when we were simplifying radicals, we take our radicand and we split it into factors that we can take the square root of. We're going to do the same thing, but if our radicand is negative, we're going to always include negative 1 as a factor. Then we look at whatever's left and determine whether or not that's something that we can take the square root of. Can I take the square root of 25? Yeah, so I don't need to split it at all. So we have the square root of negative 1 and the square root of 25. What is square root of 25? 5. And the square root of negative 1 is I. So we write our solution as 5I. That the I always comes after that whole number, okay? Or after that real number. We're going to include the rational number first, and then the imaginary unit, okay? Same thing with B. I'm going to split it into what two numbers?
9.
Not 9 and 9. Which one's a default that we always use if we have a negative radicand? Negative 1. And then we have 81. Can I square root 81? Yeah, so I don't need to split it any further. I can just have it as negative 1 and 81. What's the square root of 81? 9. So this equals 9I. And don't forget the negative that was in the front. That needs to follow along. Okay, so we have negative 9I. What about square root of negative 7? What am I going to split that into? 7. Always start with that negative 1. Factor out that negative 1. Can I square root 7? No. Does it have any factors where I can square root it? No. So it's just going to stay. We've got the square root of negative 1 times the square root of 7, which just gives us I root 7. And combine it all up together for D. What can I split negative 44 into? Negative 1 and 44. Can I square root 44? No. Does it have any factors that I can square root? So I've got the square root of negative 1, the square root of 4, the square root of 11. What is that going to leave me with? 2I root 11. 2I root 11. Okay, so break it apart, take the roots. Just remember that negative 1 is always going to be one of your factors when we have those non-real numbers, and then we make sure that comes out as an I. All right? Questions? Cool. So, again, those are really easy to confuse for each other, whether the I is on the inside or the outside. So it's never a good idea to write the imaginary unit after the radical, which is why we always write the imaginary unit before the radical. Okay? So that way we clearly know where that imaginary unit is. We usually want to avoid putting anything in after a radical just because it's really easy to make that confusion. So we're going to multiply now. Whenever we have a negative radicand, we have to write it in terms of I first before we multiply. Otherwise, we're going to kind of get rid of that negative inadvertently and end up with the wrong answer. Okay? So How can I rewrite the square root of negative 6 in terms of I? I root 6. Square root of negative 1 gives me the I. So we have I root 6. And then square root of negative 5? I root 5. I root 5. So now we can multiply. What is the square root of 6 times the square root of 5? Square root of 30. And I times I? I squared. What does I squared equal? Negative 1. So it becomes the negative square root of 30. Okay, let's simplify B. Square root of negative 8. I root 8 works. I root 8. And then square root of negative 6. I root 6. When I multiply those together, what do we get? Which will become negative. Can we simplify the square root of 48? There'll be a lot of this. The factor of 48 that I can take the root of. 16. So we can go ahead and make that negative. I squared is negative 1. Square root of 16 and 3. So my final radical is 3. Alright. C. Square root of negative 5. 5. I root 5 times root 7. 7's real, so I don't have an imaginary unit. I root 5 times I root 7 gives me I root 35. So there's our 3 solutions for A, B, and C. Write it in terms of I first before you multiply. Let me show you what happens if you don't. Okay? If you don't write it in terms of I first, you just go to multiply. What is the square root of negative 6, or square root of negative 6 times the square root of negative 5? What's negative 6 times negative 5? Positive 30, right? So we get the square root of 30. Does that equal the negative square root of 30? No. Totally different answers. Because we didn't deal with the fact that these are imaginary numbers first, that's where it's going to cause that mistake. So you always need to write it in terms of I first before you do any of the operations. Otherwise, you'll probably just get the wrong side. Division, same idea. Write in terms of I and then start simplifying. So square root of negative 80. I root 80. Square root of negative 5. I root 5. What happens if I take I and I divide it by I? Everything divided by itself is 1, right? The imaginary unit is no exception to that. Cancels out. So I'm left with the square root of 80 over the square root of 5. Couple ways to handle this. Does anyone remember what we can do if I have 2 radicals as a numerator and a denominator? I can rewrite it. Quotient rule from yesterday. Feel free to look at your notes from yesterday. If I have the square root of something over the square root of something, how can I rewrite it? Square root of what? Square root of... How can I rewrite the square root of 80 over the square root of 5? Square root of 80 over 5. Write it as one radical. The square root of 80 over 5. That lets you simplify that bracket. What is 80 over 5? 16. And square root of 16 is? There you go. Mathemagics. Welcome to math class, man. Get with the program. Square root of negative 40, what am I going to do with it? Okay. I root 40 over root 10. Okay, now what? Yes, the I will stay. Yep, we can do that. I square root of 40 over 10. Yep. So turn them into terms of I first, then go ahead and simplify your radicals. So now we're going to talk about complex numbers. Complex numbers are numbers that have a real part and a non-real part. Okay? We have what's called standard form of a complex number. That's a plus bi, where a is the real part and bi is the imaginary part. It's the part that's being multiplied by the imaginary unit. Okay, that is standard form whenever we're dealing with. Excuse me. Excuse me. Whenever we're dealing with complex numbers, you have to make sure your answer is written in standard form with the real part first and the imaginary part second. Okay, we have a couple features of complex numbers. If we have a complex number and b is 0, well, anything times 0 is 0. So even if we have the imaginary unit times 0, it's still 0. So it's not exempt from that 0 multiplication rule, which makes the imaginary part go away and leave us with just a real number. So because of this, all numbers are actually complex. Our real numbers are just complex numbers without an imaginary part. So it's a subset of complex numbers. If the other is true, where A is 0 and B is not, then we only have the imaginary part. We have a pure imaginary number. So we have these subsets of complex numbers where we have real numbers and imaginary numbers and then the complex numbers together. So 3i is a pure imaginary number. And if we have the complex and the real part, then we have a non-real complex number. And again, it always has to be written in the standard form of a plus bi. Okay? The real part plus or minus whatever the imaginary part is. Now, we can do operations with complex numbers. It's very, very similar to when we have operations with polynomials. Combining like terms, distributive property. Okay? Adding, subtracting, and multiplying is the exact same as if we had polynomials. So treat I like it is a variable, like x. The only difference is when we have I squared, we have to remember to rewrite it as -1, because we know what I squared equals. So we want to look and see my real parts are -1 and 9, and my imaginary parts are -8i and -3i. And then we're just combining like terms. If I add my two real parts, what do I get? 8. And if I add my two imaginary parts, what do I get? -11i. Combining like terms. What are the real parts for b? -3, 1, and -7. Those are the real parts. And what are my imaginary parts? 2i minus 3i minus 5i. Combine like terms. What's the sum of my real parts? What's the sum of my imaginary parts? And there we go. There's our complex number. Combining. What's the extra step we have to do when we are subtracting? Make sure you distribute the negative. Negative 1 plus 2i minus 4 minus I. And then we can combine our like terms. What are my two real parts? 4, and I add those to get negative 5. And my non-real parts to get just I plus I. Okay. Go ahead and do the same thing for B and C. Then we have a pure imaginary number. So, A0, we just have a pure imaginary number. Sometimes B will be 0 and you just have a real number. The I would go away because you're multiplying it by 0. So combine your like terms. Don't forget to distribute that negative when you're subtracting to make sure those signs are switched. Multiplying polynomials, same as multiplying complex numbers. You've got distributive property. What am I going to do with that 6i? That's 3i. So what is 6i times 4? 24i, and then 6i times 3i. 18i squared. Now what? Yes, I squared turns into negative 1, which turns this into negative 18. Is that in standard form? No, we got to move it around. So how can I move that so it's in standard form? What's going to come first? Negative 18, then what? Plus 24i. So you need to make sure it's in standard form. Standard form. All right. What am I going to do with B? Okay, walk me through it. It's 12 plus 24i minus 8i 16i squared. But what can I simplify here?
12.
Good. So I've got 12 plus 24i minus 8i plus 16. And when I combine those, what do I get? 28. Anything else? Combine the two i's to get 16i. And again, make sure it's in standard form. This means the first, the imaginary part, second. Last thing I want to talk about is powers of I. Powers of our imaginary number. So we've dealt with I and I squared. We know that I is the square root of negative 1. We know that I squared is negative 1. We can use that relationship in order to find larger powers of I because it follows a pattern, okay? And it repeats. So if we break apart I to the third, we can write it as I times I squared. Well, I squared equals negative 1. So when I multiply I by negative 1, I just get negative I. So I to the third equals negative I. Same logic with I to the fourth, but instead of I and I squared, it's I squared and I squared, which means I'd have negative 1 times negative 1, which gives me a positive 1. And then when I get I to the fifth, then I have I and I to the fourth. Well, I to the fourth is just 1, so when I multiply it by I, I'm left with I. And then I to the sixth is I squared and I to the fourth. 1 times I squared is negative 1. And then we're back at negative I again because of the I to the third. And we're back at 1. And it loops through that as we keep going up in powers, higher and higher and higher. We're going to go back to having I, and then negative 1, negative I, 1, I, negative 1, I, over and over and over. It cycles through. And you'll notice here, all of these are being compared to I to the fourth. Because what we're doing is we're breaking it down and then just multiplying it by something that equals 1, which is kind of the easiest way to look at it. So there's a shortcut with evaluating higher powers of I. It's all based on the how many times can I get I to the fourth inside my exponent. So what we want to do is we want to take this and we want to write it as I to the fourth to some power, some number of times. We need to figure out how many times I to the fourth goes into 28, which means we need to divide 28 by 4. How many times does 28 go into 4? 7 times. Do I have anything left over? No. Okay? So, because I have nothing left over, then that just means that I to the fourth 7 times is equivalent to I to the 28. Well, what does I to the fourth power equal? 1. And what does 1 to the 7th power equal? Just 1. Let's see what happens if we have something left over. How many times does 4 go into 19? 4 times. 3 left over. It would be negative 1. It goes in 4 times with 3 left over. So I to the 19th is I to the 4th 4 times I to the 3rd. That's the leftover 3. You know that I to the 4th any number of times is just going to be 1. And I to the 3rd equals negative I. We can do that with any exponent. Delaney, give me a 2-digit number. Any 2-digit number.
32.
32. How many times does 4 go into 32? Yes. Do I have anything left over? Nope. So, I to the 32 is equal to I to the 4th 8 times. That equals 1. Let's do 33. How many times does 4 go into 33? 8 times. With how much left over? 1. So, I to the 33rd is equal to I to the 4th 8 times still, because it goes in 8 times, with 1 left over. So I to the 4th to the 8th is equal to what? What is this equal to? What's I to the 4th? 1. 1 to the 8th power. 1. This is always going to be 1. That's the whole point. 1 times I. What's 1 times I? Just I. I could do 34. I would have what? How many left over? 2. So then it would just be I squared. I could do 35. How many would I have left over? 3. So then I'd have I to the 3rd. What we're really looking at is how many do we have left over? That's going to tell me whether or not it's I or I squared or I to the 3rd or I to the 4th. Okay, if there's nothing left over, it went in evenly as I to the 4th. Otherwise, it's 1, 2, or 3. We can do the same thing here with our negative exponent. We just have to use our negative exponent rule first, which says write it as the reciprocal, 1 over I to the 9th. If I divide 9 by 4, how many do I have left over? 1. You can identify how many you have left over. That's going to tell you which power of I it's going to be. Questions, comments, concerns, queries, conundrums? Cool.